Hello everyone and welcome back. My name is Mr. Covalt, and in this video I'm going to be going over the distinction between atomic elements versus molecular elements. In doing so, we're going to have to go back to our division of matter. So remember in my previous video, I looked at the division of matter in between to be divided into two categories. One was pure substances, where those were the substances that don't vary in their composition, right? It's always going to be the same amount of stuff to make up that particular substance. Like water is always going to be two hydrogen and one oxygen. And then you have this other category that I'm not going to talk about today in this video, is that of mixtures, right? Homogeneous versus heterogeneous mixtures, and that was divided based on whether or not the substance or the mixture was uniform or not. Or you could look at it and tell it's, does it look like one substance or does it look like multiple substances? So we're going to only look at the pure substances side of this. And so, again, just remind ourselves that when we divide up pure substances, we're dividing it up based upon the question of whether or not it can be broken down into simpler substances. If it can be broken down into simpler substances, then you have an element. If it can be broken down into simpler substances, you'll have a compound. And if it can't, then you have an element. But then we can divide these up further. So here, if it's an element, then we can divide it up into atomic elements versus molecular elements. And as the name implies, if you have an atomic element, that element is only made up of atoms. What that means is that you don't have atoms that are bonded together by, say, covalent bonds where the electrons are shared. So in this case, the atoms are going to be together, but they're not bonded together. They're separate, or at least they're not covalently bonded together. So this would be an example of an atomic element, helium. So helium only exists as individual atoms, right? Same for sodium. Sodium would be sodium metal would be also a bunch of atoms, together in the substance. There's no atoms that are actually like bonded together. You can't look at it and say, oh, this is a unit by itself, right? You can only look at the individual atoms together as a whole. The best way to compare this is to compare this to the molecular element. So molecular elements are elements that do exist as molecules where the atoms are bonded together into a unit. You can obviously see the unit as a separate thing and a separate entity. So for example, here we have two atoms bonded together. This is an example of oxygen. So the atoms of oxygen are bonded together to form O2. So this is the way that oxygen element exists in nature. It exists as two oxygen atoms bonded together to form a unit. This unit we call a molecule, right? So here we have two atoms of oxygen bonded together covalently to form a separate unit. So here we have we have five oxygen molecules. This would be the element of oxygen. You can see how this, if we juxtapose these two together, you can see how this is different from this. Here, you can't look at this and see, oh, here's an obvious unit. These two are together, or these two are together, or these three are together. You can't really point to something in here and say that's a unit called a molecule. Here you can, right? So here we'll call, so here we have our molecular elements. Here we have our atomic elements. Most of the periodic table, most of the elements on the periodic table are going to be atomic elements. They exist only as atoms, individual atoms in nature. There's a handful that exist as molecules in nature. So we have hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. All of these exist as what we call diatomic molecules, diatomic elements. This is where you have two atoms bonded together. And then we have a couple that are molecules with more than just two. So we have sulfur. Sulfur exists in large part as S8, and phosphorus, one of the common forms of phosphorus is P4. So this phosphorus exists in this form, sulfur exists in this form, and these exist as diatomic molecules. So there's a nice mnemonic device that you can use to remember these 7, and that is: horses need oats for clear brown eyes, right? So if you can remember that phrase, those are the 7 elements. Horses need, horses H, needs N, need N, oats, O for oxygen, for fluorine, clear chlorine, brown, Br for bromine, and eyes, of course, for iodine. So horses need oats for clear brown eyes. So that's a good mnemonic. I don't know how to add these together, so maybe you can come up with a mnemonic for sulfur and phosphorus. So here we have our molecular elements. Again, these are elements because you can't break this down into simpler substance. You just have oxygen here, but they're oxygen atoms bonded together, so they're molecules. So then over here we have compounds, and the compounds can be broken up into 2 categories. And again, we have molecular compounds and we have ionic compounds. And again, for molecular compounds, these are going to be compounds where the atoms are bonded together, where they're sharing their electrons. They have covalent bonds. So here we have covalent bonds, but here we have an element, only one kind of atom bonded together. Here we have compounds are substances that have more than one kind of atom bonded together. There's going to be different elements bonded together in the compound. So again, water has hydrogen and oxygen bonded together in a unit. So here again, you can see these separate units: 2 hydrogens, 1 oxygen, 2 hydrogens, 1 oxygen. These hydrogens belong to this oxygen. These 2 hydrogens belong to this oxygen. So they are separate units. So they're molecular. So these are molecules. So we have compounds that are molecules, and we have elements that are molecules. Okay, so remember, the definition of a molecule is a substance that has 2 atoms bonded together, right? 2 or more atoms bonded together, right? So, and those atoms can be the same or different. If they're the same, then you've got an element. You've got a molecule that's an element. If they're different, then you've got a molecule that is a compound. So molecules can be, you can have elements that are molecules, compounds that are molecules. Okay, so then compare this molecular compound to an ionic compound. And again, as the name implies, ionic compounds are made up of ions. Ions are atoms that have charge. How did they get their charge? They either gained a negative electron to be negative, or they lost a negative electron and became positive because they have more protons in their nucleus compared to the electrons they have outside the nucleus. So here, an ionic compound is made up of a positive and negative ions together. So this is going to be a crystal. It's got this crystal structure, and one of the things you notice right away is that you've got this alternate pattern in your ionic substance of positive, minus, and so on, right? So that you have the larger negative ions, smaller positive ions, right? So an example of this would be NaCl, sodium chloride. That's your table salt. And so here, this ionic compound, again, just like over here, you can see here that you can pick out the unit, right? So if I had a bunch of water in a glass and I could focus in on it and zoom in, I could pick out units, obvious units of water, right? And we call those molecules. Here, you can't pick out a unit, right? So for example, this plus right? That would be your sodium ion. The plus is our sodiums. The negatives are the chloride ions. And so if you look at this one, this sodium ion is attracted to this chloride ion, this chloride ion, this chloride ion. So what is the unit? Is it this? Is it this? Is it this? You can't tell. So there's no way to tell what the unit is. So therefore, in this case, we don't refer to the unit that of NaCl. So NaCl here, is it this Na, this Cl, this Na, this Cl, right? We don't know. So we don't call the unit a molecule. In this case, we call the unit a formula unit. So we don't use molecule for ionic compounds, right? So don't do that. We use the term formula units. And the reason, again, is because we can't look at this and point out and pick out the obvious unit and say that there is our NaCl molecule, right? We can't do that. So this is how you break up the substances, pure substances, into elements and compounds. And then we have, again, atomic elements, molecular elements, and we have molecular compounds and ionic compounds. So that's it for this video. I hope this was entertaining. I hope it was insightful. I hope you enjoyed the video and learned from it. If you did, then by all means, please like the video, hit that like button, share it with your friends, and also finally subscribe to my channel. Hit that notification bell, and when you do, make sure you click all so you can be notified by all the videos I put out. And then finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. Thanks for joining me, and have a great day.